Algebra 1, Section 12.6, Solving Rational Equations. If you're watching this video, I want to say congratulations. You've made it this far. This last section is, I wouldn't say it's the easiest one in the book, but it's not a terrible one. And I think the video will be pretty short here. We're going to be solving equations that deal with the type of fractions that we've dealt with in other sections in this chapter, in chapter 12. Okay, so we're actually going to do these two problems last, and we want to go to here. Okay, now you'll notice that on each problem that we do, total of six equations we're going to solve here in this lesson, and we'll be done. You'll notice that each one of them, the directions will say check the solution. And in every problem in your homework, I believe every single one, the directions at the top of that section will say check your answer. Very important that you check your answer, especially on these later problems, and I'll show you why. Okay? Now, you're looking at this first problem here, and if you were here, I'd maybe ask for some suggestions, and inevitably somebody suggests find a common denominator. And if you want to do that, that is not a wrong answer. You absolutely could find a common denominator. And you could change 3/8 to what would be a denominator of 8x, and then you could multiply the second fraction by 8/8. You can multiply the third fraction by 4/4. You could solve it that way. You would get the right answer. Okay, that's not the tack I'm going to take, but yes, you could do it that way. I would suggest instead that you multiply the whole fraction by the least common multiple of the denominators. So in one fell swoop, you get rid of all of the denominators at once. Okay, now let me not answer too quickly, or let me not give it away too quickly. What could you multiply through by that would wipe out all three denominators? What's the least common multiple of 8x and 2x? Well, that answer is 8x. Notice a minute ago when I said you could do it the other way, and the denominator of each fraction would end up being 8x. Well, that's what we want to use to multiply through. You're going to multiply every term by 8x. And I like to show it this way. I'm going to kind of distribute that 8x in. Really what you're doing is you're multiplying this side by 8x and then 8x here on this side as well. Okay, but that just tends to be not the way that I show that, but rather like that. Just don't forget to multiply both sides by your least common multiple. And think about this now. And I know I'm giving it kind of multiple ways here, and I'll go a little faster as we get into this, but just bear with me. When I multiply 8x by 3/8, what you would get is 24x over 8. And then you could reduce that. 24/8 reduces to 3. Therefore, you're going to have 3x. Now, that is not the way that I prefer to do that either. And I think this will help you. Try dividing first and then multiplying. You know it's going to be divisible, right? We just picked the least common multiple for a reason. So rather than multiplying 8 by 3 and getting 24 and then having to deal with numbers that are slightly bigger, how about we divide 8 by 8 first and get 1, and then, so that's 1x, and then just multiply it by 3. Either way, you're going to get 3x. The second way that I just described it, you're keeping things smaller. Similar, when I multiply 8x by the fraction 4/x, if I divide first, the x's will cancel. This is a numerator. It's like saying 8x over 1. The x in the numerator will just cancel with this x in the denominator, and all you have left now is 8 times 4. That'd be 32. And on the right side, 8x divided by 2x, if you would divide first, would simply be 4, right? And then 4 times 14 would be 56. And now you've got an equation that would be very easy to solve, just 2 steps to the answer. So the challenge is really the first step, and now we just want to ask ourselves what's happening to the variable and then do things in opposite PEMDAS order. Subtract 32 from both sides, and you'll have 24. Divide both sides by 3, and you'll have x equals 8. Now, it does say check your solution. Let's do that real quick. 3/8 plus 4 over x, and we just figured out that x is 8. Wondering if that's equal to 14 over 2x, which is 2 times 8, which is 16, right? Well, 3 plus 4 would be 7/8, and 14/16 reduces to 7/8. So it checks, and that does mean that x equals 8 is our solution. Moving on. How about this one? I'm going to employ the same idea. So think about it for a second. What would you multiply through by? If you said x squared, that would be correct. You're going to multiply through by x squared, that is to multiply every term by x squared, and that'll wipe out that denominator. It'll also wipe out this one, and this one never had a denominator to begin with, right? So all the denominators will be gone on the next line. And again, divide first. X squared in the numerator divided by x squared would just be 1. This is just 6. Back up a step. If you did it the other way, you'd multiply x squared by 6, and you have 6x squared over x squared, and then the x squareds would cancel. You'd have 6. But I think it's easier to divide first. If you adopt that, I think you'll like it. Here, x squared divided by x would just be x. That's a numerator. It's still in the numerator, and it's x. X is getting multiplied by 5. That's 5x. And then in the last, -1 times x squared is just -x squared. Okay, now we know how to solve these too. And what I would do is actually subtract 5x from both sides and add x squared to both sides to make it so that it's equal to 0 and so that the lead coefficient is positive, because probably you're going to be able to factor. Probably the easiest way to solving would be by factoring, and not the quadratic formula or completing the square, which are usually considered more difficult. So this would be x squared minus 5x plus 6 equals 0. I'm not sure I was clear on that. I added x squared to both sides, so this would be gone. I subtracted 5x from both sides, so this would be gone. That's why we have 0 here. And now I have x squared minus 5x plus 6. This is standard form. And yes, it is going to be factorable. So talked in the last section about factoring by grouping. If you are one who does that method to continue to do that, there's really no need when the lead coefficient is 1 to go off and do grouping, because it's really just the same process. We are looking at 2 and 3, both negative. X minus 2 times x minus 3. Let me double check. X squared minus 3x minus 2x would add up to -5x. -2 times -3 is +6. Okay. Now remember the zero product property. So next step here, we're trying to solve for x. If this times this gives me 0, then one of the two factors must be 0. Either x minus 2 is equal to 0 or x minus 3 is equal to 0. And x equals 2 would be the solution here. X equals 3 would be the solution here. Now let's double check. It does say check your solution. 6 over 2 squared, wondering if that's equal to 5 over 2 minus 1. Well, 2 squared is 4. That'd be 6/4. That'd be 3 over 2. 5 over 2 minus 1. 1 is like saying 2 over 2, right? So 5 minus 2 over 2, that'd be 3 over 2. Or if you went to fraction, both of those would be 1.5. So 2 as a solution checks. 2 is going to be one of the solutions. Let's check 3 also. 6 over 3 squared. I'm sorry, when I get low on this, it gets looks like I'm a 6-year-old writing. But I'm not 6 years old. 5 over 3 minus 1, wondering if these are equal. So this would be 6/9. That's 2/3. And 5/3 minus 1, which is like saying 5/3 minus 3/3, is in fact 2/3. They both check. Both of these are solutions. Okay. Now, if I can just link that back to something, why would both of these be solutions? Well, you're looking at some kind of a curve, right? And it's going to cross the x-axis at 2 places. Okay, not necessarily a parabola, but it would be a graph. If we solve this by graphing, would cross the x-axis in 2 places, and those 2 places are 2 and 3. Okay, so notice that we saw a problem where we got 2 solutions and they both worked. Keep that in mind as we do the last couple. All right, so we're not doing example 3. We're moving on to example 4. Now, notice the difference here. The last 2 problems had 3 terms. This only has 2 terms. It's 1 term on the left and 1 term on the right. And in fact, term might actually not be the right word to use, but you know what I'm saying, right? It's not. There's no addition or subtraction that's bringing in another component, if you will. So what do we do? What do we have here? We have fraction equals fraction. What do we normally do in math when we have a solving situation and it's fraction equals fraction? We call that cross multiplying. And that's what we're going to do here. right? So x squared times 1 is x squared. 4 times the quantity x plus 8, if you want to write that as 4 parenthesis x plus 8, you can. I'll just remember to distribute. That'd be 4x plus 32. If you do what I did, just make sure you remember to distribute the 4, okay? And then here again, x squared minus 4x minus 32 equals 0 is a quadratic equation that we can solve, probably by factoring. So let's try it. The easy numbers to go to for 32 would be 4 and 8. And in fact, 4 and 8 are different by 4. So that's what we want. This one would be minus. This one would be plus. X squared minus 8x plus 4x would give me negative 4x minus 32. Okay, so x plus 4 equals 0, or x minus 8 equals 0. You may not need this step. A lot of you can probably look right here and go, okay, negative 4. Negative 4 is going to cause this to be 0. Positive 8 is going to cause this to be 0. So you may not need this line here, but just in case you do, and you subtract 4 from both sides, you're going to get negative 4. Here, if you add 8 to both sides, you get x equals 8. So we think we have two solutions. We think we have negative 4 and positive 8. Let's see if that actually works. Try negative 4 first. 4 over negative 4 squared is equal to 1 over negative 4 plus 8. And again, I like to put the question mark over the equal sign because I am wondering if that is true. Okay, and I think that one's going to work. In fact, this one might also be one where both of them work. That would be 4/16. Remember, negative 4 squared is going to be positive 16. So 4/16 is 1/4. Here you've got 1 over 4. Yeah, so 1/4. So that works. Negative 4 is a solution. And I can already see that this one's going to work too. 8 squared. Wondering if that's equal to 1 over 8 plus 8. Well, 4/64 would be 1/16, and it's equal to 1/16. Okay, now listen, I promise it's coming. This one, again, had two solutions that both worked, but it's coming where we're going to have one that doesn't work. A solution, something that we think is a solution, but it actually doesn't make the equation true. Okay, so that brings us to our last example. So it must be this one, right? And again, since it's fraction equals fraction, we'll go ahead and cross multiply. Actually, let me do it this way. Let me show you their work, and then we'll come back to what would actually be something easier. They're going to cross multiply. They're going to cross multiply. And here you have x plus 3 times x minus 1. And then here you have 4 times x minus 1. They'll go ahead and FOIL this right here and then distribute this 4 right here on the next line. I assume they'll simplify this on the next line, right? The middle terms, yep. So negative x plus 3x is positive 2x. And right here is an equation that you should have no problem solving because it's quadratic. We should subtract 4 from both sides. We should add 4, subtract 4x from both sides and add 4 to make that equal to 0. And then just like the last two problems that we did, attempt to factor. And in fact, this time it's x minus 1 times x minus 1, so the same factor twice, and employ the zero product property, in which case you'll get 1. Or if we even showed it twice, you'd get 1 and 1. No real need to do that. Okay, so we think the answer is 1. Now, go back. Did we really need to do that? Oops. Do we really need to go through that process? I would think that some of you would have noticed that we really could have just multiplied this by x minus 1 and this by the same thing. Of course, that's legal in math as long as you do the same thing to the left side as you do to the right side. And this would cancel with this denominator. This would cancel with this denominator. And then you could save yourself a lot of work by just solving that right there. X plus 3 equals 4. And you subtract 3 from both sides and you'll get x equals 1. But guess what? X equals 1 is not going to actually work in this problem. Now let me just give myself some space. So we got x equals 1 here, right? We think the answer is x equals 1. And let's go ahead and check. It's not doing exactly what I want to show, but let's just go ahead and check it back into this original one. We think the answer is x equals 1. That would be 1 plus 3 over 1 minus 1. Do you see the problem? 4 over 1 minus 1. Okay? 1 is not going to be a solution here because it's causing the denominator to be 0. This is what we would call an extraneous solution. So what we thought was a solution is actually extraneous. And answer this question. If we thought we had one solution and it ended up not being a solution, how many solutions do we have? None. So in this case, we would say no solution. Now, real clear here, and by the way, this comes up pretty early on in Algebra 2. I think it's in, if it's not in Chapter 1, it's in Chapter 2 of Algebra 2. So you'll be dealing with this again soon. Call it September. What I would require for full credit here is not to just say no solution. Oh, I looked at it and I could see it was no solution. That's not proof, right? I would need to see the correct extraneous solution. I should see the work you did. I should see the fact that we came up with one, and then what you would want to do is either label it like I did, extraneous, or maybe cross it out as you say no solution, right? So we got x equals 1. It's extraneous, therefore no solution. Okay, let's wrap it up here. What about this one? 2 over c squared is equal to 2 over c squared plus 1. Now think about this. What if c ends up being 3? 3 squared is 9. And here 3 squared plus 1 is 10. Is there anything that I could have done to simplify that by multiplying both sides or whatever? The answer to that is no, because think about it, if c is just 3. I just picked a number out of the air. 9 and 10. Can you simplify two fractions that are on opposite sides of the equation when one of the denominators is 9 and the other one's 10? No. Pick a different number. Pick 1, right? So a lot of people think, 1 and 0 are usually the exceptional ones. Well, here you'd have 1 and 2. There's no simplifying to be done here. 0. Well, that's going to be a problem with this right here. So there's no way the solution is going to be 0. And in fact, watch, the solution is actually going to be no solution. So here we go. Let's cross multiply. 2c squared, when I do this, is equal to 2c squared plus 2 when I do this. And when I then subtract 2c squared from both sides, you're going to get 0 equals 2. That's a no solution situation. Not exactly the same thing as the previous example, and the reason it was no solution. The previous example, we got an extraneous solution, whereas here, we just got a false statement. And I could direct you back to an earlier lesson where that happened, and we just said no solution. Okay. And again, I always like to link these to the graph. If you graphed y equals 2 over x squared, and then you graphed y equals 2 over x squared plus 1, you would just see two graphs that just do not intersect. No solution. Okay. One more time. Cross multiplying. We would get, let's see, what would we get here? W squared, I'm going to leave it in factored form here, at least for the first step. W squared times W minus 1, that's this here. And then it's equal to W minus 1. The thought crosses the mind, do you want to distribute the W squared? I don't think so, because then you're going to have a cubic, and you don't know how to deal with cubics. So I think the better approach then would be to divide, if you can think of this, by W minus 1, right? If I divide both sides by W minus 1, not only would these cancel, but these would also cancel, leaving you with just 1, okay? Now, W squared then is what's left on the left. This is a fraction that's equal to 1, right? Not 0. 10 over 10 is 1. Negative 3 over negative 3 is 1. W minus 1 over W minus 1 reduces to 1. Okay? So, careful now. There are two solutions to this. You would want to square root both sides. And when we square root, you got to add a plus or minus. So we think we have two solutions, negative 1 and 1. Okay? We think we have two solutions. Do they both work? Well, let's check. Let's check 1 first. 1 squared over 1 minus 1 is equal to 1 over 1 minus 1. See the problem? You've got again, an extraneous solution because 1 causes the denominator to be 0. 1 is not a solution here. Just because you're going to end up with 1 over 0 is equal to 1 over 0, that doesn't make it right, because you can't do over 0. That's a divide by 0 error. So 1 is not a solution. However, negative 1 squared over negative 1 minus 1, wondering if that's equal, I forgot my question mark over there, equals 1 over negative 1 minus 1. Well, that would be 1 over negative 2. Oh, trying to get tricky. This would be 1 over negative 2, and so would this be 1 over negative 2, or negative 1/2 is really what that is. So this one checks. So out of our two solutions, we thought that they were w equals 1 and w equals negative 1. The w equals 1 proved to be extraneous. Only negative 1 is a solution. Okay. Now, before we end this, let's go all the way back. Yes, again, we could have approached this one the same way we did the one on the software. You could have multiplied both sides by w minus 1, in which case you just have w squared equals 1, and you're really to this point right here. Okay, if you can see that. Some of the problems it'll be like that, and some of the problems it won't. All right, so that's it. That's a wrap. Do the homework, and I'm also going to put a chapter review assignment on, and I'm also going to post the exam review, although I'll probably put that in an email, so I don't really need to be saying that to you right now. Anyway, thanks for tuning in.